This is section 9.3, arcs and central angles. We begin with the definition. A central angle of a circle is an angle with its vertex at the center of the circle. So in the picture I've drawn here, angle YOZ is a central angle of circle O, because the vertex of angle YOZ, which is O, is the center of the circle. Each central angle of a circle marks off two arcs on the circle, what we call a major arc and a minor arc. The minor arc is the smaller one, which is arc YZ here. So we write arcs with the two letters and a curved line over top of it. YZ is the minor arc. The minor arc is the one in which all of the points on the arc are on the interior of the angle. Or another way of saying that is that the minor arc is the smaller one. The major arc is this one out here. The whole rest of the circle. That's called the major arc. If I wanted to label that, I'd have to give myself a third point on the circle, so let's call that W. And I could say YWZ is the major arc. Because if I just used Y and Z again, I'd be implying it's the minor arc between Y and Z. If I want to label the major arc, I have to give myself a third point and label it by all 3 points and go around. So every central angle gives us two arcs, the major arc and the minor arc. Together, the major arc and the minor arc make the entire circle. If the central angle is actually a straight angle, so it's 180 degrees, then the line, since it goes through the center, must be a diameter of the circle. And the two arcs, the major arc and the minor arc, are actually equal in size. No, not one is smaller than the other or bigger than the other. They're the same size. They're each half of the circle. And those are called semicircles. So if I give myself a point W and a point, say, T, then I can say YWZ, arc YWZ, and arc YTZ are the two semicircles formed by diameter YZ, which is a segment, not an arc. So I have two semicircles formed from a diameter. Basically, they're each half of the circle. The measure of the minor arc, the size of the minor arc, is defined to be the measure of its central angle. So we're actually going to measure the arcs in degrees, like we do the angles. For example, if in the first circle on the left, AOB, let's say that is 80 degrees. That's an 80-degree angle there. Then I'm actually going to say arc AB, that minor arc, equals 80 degrees. The measure of the minor arc is equal to the central angle that forms it. So if angle COD over here is 130 degrees, then we would say arc CD equals 130 degrees as well. So the angle COD would equal 130, and the arc CD would equal 130. On the right, I've got a diameter, a straight angle, which is 180 degrees. Angle EOF, which is a line, is 180 degrees. So that means each semicircle, so if I label point G and a point H, arc EGF going to be 180 degrees, and arc EHF going to be 180 degrees. So a semicircle always has a measure of 180 degrees, which means the entire circle is 360 degrees. The measure of a major arc is 360 minus the measure of its minor arc. So in the green circle, the top one, the major arc will equal 360 minus 80. 360 minus 80 is 280 degrees. Circle in the middle, the major arc is 360 minus 130, which is 230 degrees. The circle on the right, each one is already 180. 360 minus 180 is 180, so it still is logically consistent. The measure of the minor arc then is the measure of the central angle. The measure of the major arc is 360 minus the measure of the minor arc. So always find the minor arc first. Way back at the beginning of the year, in September, we had the segment addition postulate and the angle addition postulate, which said if we've got two adjacent segments, two segments that share the same endpoint, we can add them together to get the whole segment. If we have two adjacent angles, two angles that share the same ray in the middle, then we can add those two angles together and get the whole angle. Now we have the arc addition postulate, which says if we've got two adjacent arcs, we can add them together and get the whole arc. The measure of the arc formed by two adjacent arcs is the sum of the measures of those two arcs. For example, let's say arc AB here is 110 degrees. And let's say arc AC is 90 degrees. So arc AB is 110, arc AC is 90. So arc BAC is going to be arc AB plus arc AC, which would be 110 degrees plus 90 degrees, which would be 200 degrees. Pretty simple and basically common sense. If two arcs share an endpoint, then they're adjacent arcs, and so we can add the two sums, we can add the two numbers together and get the measure of the whole arc. Another intuitive idea is the idea of congruent arcs. Congruent arcs are arcs that are either in the same circle or in congruent circles, circles of the same size, that have equal measures. So I've got an arc AB here that has a 100-degree measure, and I've got an arc CD here with a 100-degree measure. If circle P is congruent to circle Q, then arc AB is congruent to arc CD. How would I know that the circles are congruent? Well, say I knew that they had the same radius, then they would be congruent. But the circle on the right clearly is smaller than the two circles on the left. It has a smaller radius, it's a smaller circle, so it's not congruent to the two circles. So EF equals 100 degrees, but EF is not congruent to arc AB or arc CD because it's not in a congruent circle. And one final theorem. In the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent, which makes sense. We measure the minor arc by the measure of the central angle, so if those central angles are congruent, then we know that the arcs they form are congruent as long as those arcs are in either the same circle or in congruent circles. Here's an example. We're going to give the measure of each angle or arc from the picture that we've got. So let's find arc WX. Well, O is the center of the circle, so line YT is the diameter of the circle. So to the left of YT is a semicircle of 180 degrees. So this entire thing is 180 degrees, that half of the circle. I know I've got 50 degrees with WT. I'm going to have 30 degrees with XY, how much is left for WX? Let's take 180 minus 50 plus 30. Well, that's 180 minus 100 minus 80, which equals 100. The whole semicircle is 180. Take off the 50 I've got at the bottom, the 30 I've got at the top. That's 80 total I'm taking off from the 180, which leaves me with 100 for WX. Number 2, find angle WOT. Well, arc WT equals 50 degrees according to the picture, so angle WOT equals 50 degrees because that's the central angle that gives us arc WT. The measure of the arc and the measure of the minor arc and the measure of the central angle are the same. And number 3, arc XYT. So XYT, get rid of those so we can see it more easily. XYT is that, which is more than half the circle. But I know exactly how much more, because arc XY is 30 degrees. So arc XYT, according to the arc addition postulate, is going to be arc XY plus arc YT. Arc XY is 30 degrees. Arc YT is half of the circle, because YT was a diameter. Half of a circle, the semicircle, is 180 degrees. So arc XYT is going to be 30 degrees plus 180 degrees, or 210 degrees, using the arc addition postulate. So here are your immediate practice problems. Find the measure of angle 1 in each picture. Angle 1 is a central angle in each picture. So the red dot in the middle is the center of each circle. Find the measure of angle 1 in number 1, number 2, and number 3. Make sure you draw the pictures. And good luck. That is the end of section 9.3.